Previous session, we have completed this RACH-related test case study. Today, we are taking up this downlink SCH data transfer and then uplink SCH data transfer. So first, let us start with downlink SCH data transfer. In downlink SCH data transfer, eNodeB is the one that transmits the data by making a downlink SCH transport block. And please remember, all the test cases that we are studying are test cases from the UE point of view, mobile point of view. So eNodeB is going to be the system that we are simulating. UE is the real product here. So when you take downlink SCH, eNodeB takes the responsibility of forming the downlink SCH and send it to UE. UE simply need to receive the downlink SCH and process it. So another way of telling it, downlink SCH multiplexing is done by eNodeB and demultiplexing is going to be done by mobile equipment. So because at the time of forming the downlink SCH, eNodeB need to multiplex the logical channels to form this downlink SCH transport channel. Same way, UE receives this downlink SCH transport block and demultiplexes the data, and then the demultiplexed data would be sent to the logical channels. Okay, so first test case, correct handling of downlink assignment dynamic case. So downlink assignment is being done in a dynamic way. So UE is in UTRA RRC connected state. UE receives downlink assignment on PDCCH channel on the UE CRNTA, and then it receives the data in the associated subframe, and UE performs the ARC operation. UE sends the ARC feedback on the ARC process that is indicated. So it's a positive operation completely. UE is in UTRA RRC connected state. When UE receives the downlink assignment on the PDCCH with CRNTA unknown by the UE, but the data available in the associated subframe, then UE does not try to receive the transport block or never sends any ARC feedback. It's sensible because the data is not scheduled for you, not on your CRNTA. Straightforward, a very easy scenario to understand. So when the CRNTA matches with the CRNTA on the PDCCH channel, then it should be considered as data is configured for you, and you need to receive the data and send the feedback. But if it is not for you, not on your CRNTA, it is somebody else's CRNTA, then there is no point in downloading the data or sending the ARC feedback. Okay. System simulator should contain one cell, and RRC connection setup must be done according to the table that is specified here. So that means what configuration that eNodeB must do for mobile, that configuration is pre-decided. And RRC connection reconfiguration, because during establishing the data radio bearers or DRBs, reconfiguration will take place. RRC connection reconfiguration takes place. This RRC connection reconfiguration would be used for a lot of different purposes. Like it can be used for uh, it can be used for handover. It can be used for setting up the radio bearers. So for setting the DRB, data radio bearer, you require reconfiguration. So while setting the radio bearer, what parameters or IEs that must be used, their values must be used, that is specified in this particular table. 7131332. Here 7131331 contains setup related messages. So basically, mobile equipment, when it starts in the idle mode, before it moves into the connected state, uh, as part of this particular test case, four important messages will take place. So this is the mobile, and this is our simulated inode being, or nothing but our SS, system simulator. So UE sends RRC connection request, and system simulator need to send RRC connection setup. So in this setup, what messages must be there? What parameters must be used in this setup need to be pre-decided, because this is a system simulator. It is not a real inode B. If it is a real inode B would have decided on its own what kind of details must be there in the setup message. But because it is a testing environment, we have to, as a tester, we have to decide. Now, 3GPP is saying that, hey, the system simulator software that you design must be following the rules that are specified in this table while sending the information for the setup. So this table is applicable. Now mobile sends RRC connection setup complete. That's okay. Anything that is coming from the mobile has capability to prepare. We don't need to assist mobile. Mobile is independent. But now, at the time of setting up the data radio bearer after activating the security, so you have to send something called as RRC connection reconfiguration request to create a data radio bearer. So in this again, what parameters must be used? What is the values of the information elements inside this message that is suggested as per this table 71311 332. So there is one table for this and one table for this, two messages which system simulator is sending towards the UE. Next, UE preamble for the UE, and please don't confuse, this preamble is not a RACH related preamble. Preamble means what is the initial setting that we expect on the mobile side. That's the meaning of the preamble. So UE must be in state loopback activated. So any data that is sent in the downlink need to be sent in uplink. And also from 36508, the clause 405 is executed with all the parameters as specified in the procedure, except that the RLC SDU size is set to return no data in uplink. So loopback is activated, but uh, SDU size is not set. But it's kind of a dummy loopback that is activated. Only status reports will come back normally when this is RLC SDU size is set to return no data in uplink. So what is the order of execution? SS transmits the downlink assignment because mobile, as part of the preamble, we are considering the mobile is already in this state 4 loopback activated state. That means already RRC connection is completed, and data radio bearer creation is completed, and loopback activation is completed. All steps will be happening as part of the preamble. So what are the sub-steps that are present to move the mobile equipment to state 4? That will be explained in 36508. They are not mentioned in this particular behavior. So this table contains only main behavior. After the mobile equipment already moved into this particular state 4. So we are at step 1 itself, we have to consider that already mobile is in state 4. That means loopback is activated. Mobile is already in that state. Okay, so what happens in this case? The SS transmits a downlink assignment, including the CRNTA assigned to the UE on PDCCA channel with the CRNTA matched to the UE CRNTA. See, of course, you can ask when the CRNTA is allocated to the mobile during RRC connection procedure as part of moving the mobile to this particular state 4 scenario. So exactly the same CRNTA would be used as the reference on PDCCA channel to allocate the downlink resources to the mobile. System simulator transmits in the indicated downlink assignment RLC PDU in the form of a MAC PDU. By preparing a downlink SCH MAC PDU, it transports it on the PDE SCH channel based on the resources that are allocated. Of course, we have to check, does UE transmit the ARC feedback on the PUCCA channel? We'll wait for that. So this is the message expected from the UE to system simulator. If this message is sent, then we assume that uh, you know the test case verdict is passed because the operation is successful. Downlink SCH receiving the operation is successful. Now SS again transmits a downlink assignment information on the CCH channel with an unknown CRNTA, not the one that is allocated to the UE. Then if the MAC PDU is scheduled and sent, we are again waiting for ARC acknowledgement on the PUCCA channel in the uplink channel. If received, the test case must be announced as failed, not passed. Because this is not the data that is for this particular subscriber, as the CRNTA is a unknown CRNTA. So there is no difference in operation. Basically, like when you see the description and the steps here, are both are looking almost same steps. But in which case the test case
Sir,
must be, yeah.
sir, if the case is in the third step only the case is failed, then
Yes.
we will
Then
be
you write a
going
bug
for the
report.
further.
Then you raise a bug report, wait for the bug to be resolved by the development team by releasing a new software. By installing the new software on the mobile phone chipset, you will have to again execute the test case. That time what happens? The third step will be passed. Then it might be failed in the sixth step. So multiple times bug can happen. But whenever a bug is raised, whenever a bug occurred, then itself we stop the execution of the test case. We'll raise the bug report. So if we have, for example, we are having one test case, doesn't mean that we'll only find the one bug. Need not be. For example, right now, UE is supposed to send two messages totally in the uplink. In any one of the steps, the test case may be failed. You don't know in which step the test case will be failed. So you can find one bug here, you can find another bug here. Possible, definitely possible. Understanding that? MAC main configuration for the SRB, timing alignment timer dedicated is set to infinity. So without causing any timing alignment issues. We don't want timing alignment related problems here. That's one thing that we are concentrating. So this MAC main config SRB would be part of your RRC connection setup. And RRC connection reconfiguration, uh, it is RRC connection reconfiguration information should be the one that is present from this particular document 36508, the document that we have checked in this particular table, whatever the parameters that are present in this, exactly the same parameters must be set for this particular test case. So you will be referring to this 36508 document a lot of number of times, because whatever the values that system simulator must set to the the messages it is sending to the UE must be all of them must be coming in from this document itself, 36508, most of them. So this 36508 is predefined configurations, different configurations. For every test case, we will be picking up one configuration. So for this particular test case, they are picking up the configuration that is mentioned in this table 4618. So if you open this document, if you go to the table, then you know exactly what configuration is prepared there. So for this test case, that configuration matches. And radio resource config dedicated, Mac main config is not present. So that means, the values must be taken, derived from this particular table again, 36508 table 46316. So we can refer to these tables in those documents also, in that document also, 36508 document also. Okay, next test case. Correct handling of downlink assignment, semi-persistent case. A dynamic case, resources are always allocated with the help of the PDCCH only for one subframe. In the next subframe, again the resources will be need to be allocated on the PDCCH again. But in the semi-persistent case, whenever resources are allocated, they are like semi-persistent. They are valid for some amount of time. So what is the situation? UE is in UTRA RRC connected state with the DRB established, and SPS configuration in downlink is enabled. Semi-persistent scheduling configuration is enabled. In this scenario, UE receives a downlink assignment addressed to its SPS CRNTI. We have learned about this SPS mechanism. So there is a special RNTI allocated to the mobiles who have got this SPS configuration enabled, called as SPS CRNTI. On top of a CRNTI, of course, CRNTI also would be available. Plus the SPS CRNTI would be again available. And in subframe number Y, with the NDI set as 0, new data indicator value set as 0, UE starts receiving the downlink MAC PDUs in subframe numbers Y plus N star semi-persistent scheduling interval downlink, where N is the positive integer starting at 0. So N number of times, every interval you will be receiving in the corresponding subframes, you will be receiving the PDUs. That's the operation. Because in semi-persistent scheduling, whatever the resource that is allocated will be repeated N number of times with a interval, with a scheduling interval, starting from the subframe number Y. Because that is what semi-persistent scheduling is all about, allocating the resources multiple times. So there are a lot of scenarios in this semi-persistent scheduling. Second, again, DRB established and stored downlink SPS assignment to receive the MAC PDUs at these particular junctures. Ensure that UE receives the downlink assignment addressed to its SPS CRNTI in subframe number P with the NDI set as 0, where P is not is equal to Y plus N star semi-persistent scheduling downlink. If UE receives the downlink assignment addressed to this, UE starts receiving the subframes and stops the receiving after these many number of times. We have to validate whether UE is stopping it or not. So we are earlier we are only verifying whether it is starting to receive. Here it is also validating when it is stopping. So it stops after receiving the n number of times. It has to stop receiving because your semi-persistent scheduling is finished. Semi-persistent scheduling is not permanent. It's going to be repeated n times, means it will be repeated n times. The resource will be available n times. After n times, resource won't be available for you. Now, UE is in RRC connected with the DRB established, and downlink SPS assignment is received to receive the MAC PDU. That configuration is stored and ready to download it this way. So subframe number P plus N into semi-persistent interval downlink. When UE receives a downlink assignment addressed to SPS CRNTI in subframe number Z and with the NDI set to 1, where Z is not is equal to this particular thing, then UE receives the MAC PDU in subframe number Z as per the new grant for the SPS CRNTI. So this is reassignment of the resources for the SPS CRNTI. So that means that in whatever the subframes that are already known to the mobile from the previous arrangements, we are deviating from that arrangement and we are assigning something else, some other resources in some other subframe. We are changing the allocations for SPS CRNTI in the middle. Now then what should happen? UE immediately start receiving the data that is allocated according to the new grants, as per the new grants. So that's the point. So again, it is configured for the downlink SPS assignment. UE receives a downlink assignment addressed to its CRNTI with in subframe number P, where P is equal to exactly the same subframe on which you are receiving the semi-persistent data as well. So that time UE have to process that data also that is arriving on CRNTI. For example, some logical channels will be operating on CRNTI, some logical channels are operating on SPS CRNTI, because both are possible. Mobile must be operating with both RNTIs at the same time. So when you are already receiving semi-persistent scheduling data scheduled on a particular subframe, in the same subframe, you are also scheduling resources for CRNTI to check whether mobile downloads both of them. Actually, mobile must. If mobile is receiving SPS CRNTA, that is not a like that is not a escaping point to escape from receiving CRNTA. No, it should not be. UE is in U to RRC connected state. Again, uplink grants are stored. UE receives RRC connection reconfiguration, including SPS configuration with the SPS configuration downlink set to disable, and result in downlink SPS grant deactivation. The moment deactivation takes place with the help of the reconfiguration, then UE deletes the stored SPS configuration and it should not be receiving any downlink PDUs. That are about to arrive in the coming up frame numbers on that particular resource allocations with that particular SPS CRNTI allocation mechanism. Any further resources any further data that arrives must not be received by the mobile. Common sense again, because the SPS CR configuration has been disabled. Semi-persistent scheduling has been stopped. Maybe that particular logical channel or the application that is using the logical channel has been disabled. Application is dead. There is no more requirement of SPS mechanism anymore. So it should be stopped. So again, SPS assignment is configured. UE receives a PDCCH address to its SPS CRNTI with NDI set to 0, where P is not equal to any of these subframes. Then UE sends ACK to the SS and release the configured SPS assignment and stops receiving the MAC PDUs in these subframes because it is addressed. New data indicator is set to 0. So it will be considering that there is no new data that is going to come in. So it has to stop the receiving in this particular scenarios. So these are different scenarios. How do you calculate the subframe number is based on this formula. This formula is coming from the specification itself. 10 star SFN, system frame number plus subframe number modulo 10,240 will give you the SF number, your subframe number that you have to use. So this, these are all the conformance requirements. Okay, system simulator is going to have one cell. UE settings are none. Preamble is UE is in loopback activated state. We are having SRB2 and DRB is used from this 36508 document from this table, the configuration for SRB2 and DRB. Uplink RLC SDU size is set to not to return any data. So that means even though the loopback is activated, it is only supposed to send status reports. It is not supposed to do any data sending. So in loopback also two situations. At RLC level, we require something called as status reports. You will understand it when you listen to RLC classes. So once the loopback is activated, so you can make use of this loopback to send status reports or to send the data that is received in the downlink direction. In this case, it is not returning any data that is received in the downlink direction, but simply maybe sending acknowledgements at RLC level also. So there are a lot of steps in the test procedure. SS transmits downlink assignment using the UE's SPS CRNTA in subframe number Y. NDA is equal to 0. Downlink SPS grant. So in this subframe number Y, downlink MAC PDU containing the RLC PDU, sequence number at RLC PDU level is 0. On uplink, UM and DRB. UM stands for unacknowledged mode. This is the RLC wording. You will understand it in RLC. RLC can be working in 3 modes: UM, AM, and TM. So you learn that in RLC classes. So you need to listen to this RLC classes as fast as you can. Things will be more clear. So RLC is working in UM mode, and its sequence number starts from 0. The RLC PDU sequence number is 0. So in RLC, for the PDU, sequence numbers will be there. So then the MAC PDU would be sent by attaching RLC PDU inside it. system simulator will dispatch. Now, once receiving it, does the UE transmit a HARCAC? We have to validate it. A value verdict is going to be set to pass if HARC acknowledgement is received, sent from the mobile. Of course, system simulator validate whether HARC acknowledgement is received on the physical channel, PUCCH channel or not. If received, we announce the test verdict as passed and we continue to the next steps. Otherwise, here itself the test case can be failed. Now, the SS transmits in subframe number y plus x into semi-persistent scheduling interval downlink, another downlink MAC PDU containing RLC PDU sequence number 1 on the DRB. Again, does check UE transmits HARCAC, again sends it, pass. Next time, here the things are getting changed. The SS transmits the downlink assignment here on PDCCH channel assigned against UE's SPS CRNTA in subframe number P with the NDA value set to 0, new data indicator value set to 0, where y plus x, so this y plus x is the next frame, is less than p less than y plus 2x. So this p value is in between these two things. This p value is in the middle of these two things. So downlink SPS grant. Now, after making the modifications, SS transmits the data in the subframe number P, downlink MAC PDU with sequence number set to 2 at RLC level. And of course, we have to check whether the acknowledgement is received or not. Now the arrangement has been changed. Earlier arrangement is not getting continued. Now the subframe is P. Starting subframe is going to be P. So again, test case is passed when HARC acknowledgement is received. Okay, next. SS is transmitting y plus 2x again. In between y plus x and y plus 2x, we already attempted sending data once on this SPS CRNTA at pth subframe. Again, y plus 2x, when we are transmitting the downlink MAC PDU, if UE sends the HARC feedback, the test case will be announced, should be announced as failed. Why? Now what happens is, after the arrangements have been modified to P, because the SPS CRNT arrangements have been modified to P, it should become P plus X, P plus 2X, you will be receiving the data, not Y plus X and Y plus 2X. See, first you have received on Y, then Y plus X. Next, if this procedure is continued, you would have expected to receive it on Y plus 2X. You would have received the next downlink SCH transport block. But after receiving Y plus X, Y and Y plus X, what did you do? In between, you chose one subframe P. In the middle of Y plus X and Y plus 2X, you choose a subframe P, and you have rescheduled the resources for this SPS CRNT on P. On that P subframe, you have already transmitted a MAC PDU, and for which you have already received the HARC acknowledgement on P. So after P, you are again attempting to send the data on Y plus 2X. This is deliberate. You know that mobile should not receive on Y plus 2X because this arrangement is discontinued. Y plus X, Y plus 2X, Y plus 3X arrangement is discontinued. Now the arrangement is P. Next arrangement should be P plus X, P plus 2X. So that should be the next arrangement because we already changed the arrangement. Okay, so what should happen now? deliberately, what are we doing? We are sending it on y plus 2x. If the mobile downloads this RLC PDU with the sequence number 3 and it sends a ARC acknowledgements or negative acknowledgement, anyone, doesn't matter whether it is ARC, ACK or NAC. In both cases, we'll announce it as failed. We'll announce the test case as failed. Now SS transmits in subframe number P plus X, a downlink MAC, again repeating the same RLC PDU, sequence number 3. And here deliberately, CRC is calculated in such a way that mobile equipment will find the CRC error. That means that we are causing the CRC error deliberately. So we are making the system simulator work in a wrong way, send the wrong message to the mobile with the wrong CRC. Of course, now what mobile is supposed to do is send a ARC NAC, negative acknowledgement we are expecting. If negative acknowledgement is received, the test case is passed. If acknowledgement is received, test case must be announced as failed. Why? Because we deliberately prepared a wrong CRC, but if mobile did not report NAC, but instead it reported ACK, that means something is wrong on the mobile side. We must announce the test case as failed, not passed. If ACK is sent. So here every step is important. At every step, every stage, the test case can be a failure. Now SS transmits the downlink assignment using UE's SPS CRNTI starting from subframe number Z this time. NDA is set to 1, where you are going to have the Z value in between P plus X and P plus 2X. And now you retransmit in the subframe number Z the same PDU because the previous one was failed, negative acknowledgement. So this time we are expecting acknowledgement in Z subframe passed. Now, so again, same step is repeated. In P plus 2X, we send the data. But this time, P plus 2X, when you are sending the data, this data is to be received by the mobile when the sequence number value is set to 4 and the mobile should send the acknowledgement. Why? Because here NDA is toggled, NDA is set to 1 here. So that means you are retransmitting the PDU because earlier transmission was failed, earlier transmission was negative acknowledged. So this is the retransmission. So we are allocating a special resource at the Z just to retransmit the packet between P plus X and P plus 2X. This in some subframe Z, we are performing the retransmission operation for the PDU that is failed to be received. So, but at P plus 2X, the resources will be resumed and you will be scheduling the MAC PDUs and your ARC acknowledgements will continue.
Hello, sir.
Yes, sir.
Sir, one doubt. In this retransmission, this sequence number will change or it will be the previous one? If in any, for example, in previous sequence number 3.
Sorry, your voice is low. Wait a minute. Yeah, can you please speak a little closer to your mic, Subin?
Okay, sir, in sequence number 3, if any failed gate, then we will retransmit. The sequence number should be the previous one, no? It should be 3, no?
Yeah, first time when we have transmitted deliberately, when what we did, prepare a CRC RNS. So we know that it is a
Okay.
ARC NAC. We are retransmitting the same PDU once again. Same MAC PDU, the one with the RLC sequence number 3 only. We are retransmitting, but in Z subframe number Z, not in P plus 2X. In subframe number Z only, we are retransmitting it. That time we are transmitting with sequence number 3. Next time in P plus 2X, the next possible uh, semi-persistent scheduling transmission opportunity, we are using sequence number 4. We are incrementing it. Only sequence number 3 need to be repeated once. Next time in the P plus 2X, we are continuing with sequence number 4. Clear?
Okay. Okay.
Simple thing. In P plus X, in P plus X, we are transmitting which one? Sequence number 3. In P plus 2X, we have to transmit sequence number 4. But we know that P plus X transmission will be a failure because we're deliberately calculating wrong CRC. Mobile is reporting NAC. So in between P plus X and P plus 2X, before we move further to the next PDU, we are in the middle of the subframes between these P plus X and P plus 2X in subframe number Z, we are arranging the retransmission of the sequence number 3rd MAC PDU itself. We are arranging the retransmission of that. And we are receiving acknowledgement, so we know that now it is successful. Okay. Next. So yeah, P plus 2X passed. Okay, next. Now we are scheduling the resources on CRNTI, downlink grant for CRNTI on PDCCA channel. In what time? P plus 3X. So P plus 3X, we will be transmitting maybe 2 PDUs on 2 different uh, radio bearers, 2 different UM entities. P plus 3X, we will be transmitting one RLC PDU. The RLC PDU number is something. And you will be transmitting one more MAC PDU containing RLC PDU sequence number 4. So 2 things you are configuring inside this MAC PDU. And for that, you expect ARC acknowledgement. Next. SS transmits the PDCCH physical downlink control channel with SPS CRNTI as the identity. So you start from subframe number Q. NDA is set to 0, where Q is between P plus 3X and P plus 4X. So ARC acknowledgement, but in this, you will be reporting. Before this, already reconfiguration is sent. So it is downlink SPS explicit release by whenever it is set to NDA is set to 0. Now after releasing, this acknowledgement is for the actual packet that is received. Acknowledgement is sent. Now, because the release took place, from here onwards, if you send any MAC PDUs on any P plus 4X or P plus 5X, if mobile sent ACK or NAC, then the test case will be announced as failed because release already took place for the SPS arrangements. Again, you are going to transmit downlink assignment again for SPS CRNTA, and subframe number P plus 5x, ND is equal to 0. Now in P plus 5x, if you transmit any PDU, then it should be acknowledged in this particular scenario. Here we are granting the resources, not releasing it. We are re-granting. So again, passed. So if you release the resources during the granting, if you send the data, we should not expect any acknowledgement or negative acknowledgement. But if you properly grant the resources, then there will be an acknowledgement if everything is good. Now, SS transmits RRC level message to completely remove this SPS configuration itself. Disable the SPS configuration by using a RRC message. Because the SPS configuration always will be done by RRC, the initial configuration. Later, which resources are going to be used for semi-persistent scheduling, that will be indicated on the PDCCH channel continuously. But the settings, the primary settings like setting the SPS, CRNT, etc., is the duty of RRC. So by using RRC procedure, system simulator is communicating to UE that I'm disabling the semi-persistent scheduling that is configured for you in the downlink operation. So UE transmits RRC connection reconfiguration complete, meaning is it is accepting to the semi-persistent scheduling release. From this moment onwards, if you send the data on any P plus NX, then if you transmit the MAC PDUs with RLC sequence numbers, above sequence number 5 onwards, greater than 5, if you keep transmitting them for all of them, you are not expecting any kind of AX or NAX. If any AX or NAX are received, it should be failed, because the resources that are allocated for this particular user on P plus NX, those things, mobile equipment should not be downloading that transport blocks, because the entire release took place by using RRC mechanism. This is not even temporary resource releasing. This is like permanently moving the mobile equipment away from the semi-persistent scheduling. So that's the scenario. And in RRC connection reconfiguration, what you do is this semi-persistent scheduling downlink, what configuration that you expecting. So number of SPS processes are 8, 7. For FDD it is 8, and for TDD it is 7, etc. are set. Semi-persistent configuration uplink is not present. Only downlink we are configuring. This is during the configuration, is part of the preamble. Before the mobile equipment moved into the SPS state. That is what is the meaning of preamble. But this is in the step 30, when we are releasing the semi-persistent scheduling. That time RRC connection reconfiguration contains SPS configuration downlink set to disable. Because it is set to disable, it will be stopped. Uplink is anyway not present, uplink configuration, because this test case is not about testing uplink, it's about downlink. Okay, next. 7133. MAC PDU header handling. How MAC handles its headers. That's the test case is about. UE is in RRC connected state. UE receives a MAC PDU containing an AMD PDU that is larger than 128 bytes with padding at the end. UE successfully decodes the MAC PDU and forwards it to higher layer. So here we are checking the decoding. How do we know that whether it is sent to higher layer or not? If it is sent to higher layer on the UE, UE is RLC, because it is working in AMD PDU state, meaning is acknowledged mode. RLC entity will send the acknowledgements. it will be sending. So you will understand that in RLC. From that, you know that it is sent to higher layer successfully. Because once received, RLC is supposed to send acknowledgement report for any PDUs that it is received in AMD PDU, in the AMD mode, AM mode. Same situation, that is smaller than 128 bytes. Even that must be successfully decoded and sent to higher layers. Connected state, UE receives a MAC PDU containing with no padding, even that also should be sent to higher layers. This padding, no padding, etc., these are the cases at MAC level, MAC transport block containing the padding. Again, in the state, MAC PDU containing multiple MAC SDUs containing the AMD PDUs with no padding to the same AMD, to the same logical channel. So UE successfully decodes all the PDUs, forward it to the higher layer. Of course, there is a possibility MAC can multiplex the data from same RLC, multiple PDUs. You can put together and form the transport block. MAC can multiplex the RLC PDUs by taking from multiple different RLCs put together. It can do it. Or it can also take it from the same RLC also, multiple PDUs put together. So here we are always testing the demultiplexing properties of the UE, successfully decoding and demultiplexing. Because in downlink SCH case, UE is just a receiver of the downlink SCH, not a multiplexer. It is a demultiplexer. So we are validating all the 4 scenarios. So logical channel IDs and all those things are according to these requirements. So preconditions, we require one cell and UE must be in loopback activated state, and uplink RLC SDU size is not set to return any data. So we should not send the uplink data, but maybe status reports would be sent in this scenario. Okay, now starts the full explanation, like in what step what happens. SS transmits a MAC PDU containing RLC SDU of size 130 bytes in an AMD PDU sequence number 0 onwards with polling bit set to 1. This polling bit is actually in RLC level. It is used at RLC protocol level. This is a mechanism to request for the status report, this polling mechanism. Whenever the polling bit is set to 1, status reports would be sent. And 5 bytes of padding. MAC header contains 2 MAC subheaders, where the first MAC subheader is RRE LCID FNL, 3 byte subheader should be there. This is all the preparation that ENODB is doing, or the system simulator is doing. Of course, FNL must be 3 byte. F flag should be set to 1, and length field must be 15-bit length field. That's why it is a 3 byte subheader in this case. And extension bit is set to 1, indicating that there is one more subheader. So F is set to 1, logical channel ID is set to 3. That represents your DRB, data radio bearer. Typically logical channel ID 3 for data radio bearer. And length field set to 132. 130 bytes of AMD PDU and 2 bytes of the header, RLC level header. Totally it is 132 bytes. Next. The second MAC subheader is a padding control 1 byte to specify the extension bit set to 0. It is containing only RRE LCID, and LCID is set to all ones. This is 31. Whenever it is set to 31, the remaining that will represent padding. So these are the same things that we have learned as part of our MAC theory sessions. So such a MAC PDU is generated and sent from the system simulator to the UE. MAC PDU is sent with these details. So RLC SDU is 130 bytes. Meaning is RLC PDU size will be 132, including 2 bytes of RLC header. 2 bytes of RLC header plus 130 bytes that is received from the PDCP. It becomes 132. That 132 arrives at MAC. So we are adding 5 bytes of padding. So what is the total size that is sent if you calculate? MAC containing 2 subheaders. One is 3 byte subheader. Second one is 1 byte subheader for the padding part, which is only containing RRE LCID. LCID value set to 31. So total 4 bytes. Then 132 bytes of RLC PDU. Then 5 bytes of padding. So total MAC PDU size or MAC transport block size is this much. 4 plus 132, 136 plus 5, 141. So 141 bytes is the MAC PDU size. Now we will do the validation. After sending this data from system simulator to UE, we need to perform a check to see if it is perfectly decoded by the mobile or not. So here we are not caring about the HARC level acknowledgement for the transport block. Of course, mobile will also send HARC level acknowledgement, but here we are concentrating on RLC status PDU. So UE should transmit a MAC PDU containing RLC status PDU acknowledging the receiving of AMD PDU that is sent in the first step. This happens at RLC level. You will understand what is the meaning of RLC status PDU once you study RLC sessions. Some of you already completed RLC sessions. That's good. Remaining people, yes, you have to finish it fast. So you have received the RLC status PDU for acknowledgement sequence number is 1. That means 0 is received successfully. Okay, great. Next. So everything is good, but this time we are sending only 40 bytes of data and 5 bytes of padding. So everything is same except that change. 42 bytes is only the RLC PDU size, including the header, plus 5 bytes. So it is going to be 2 bytes is one subheader, 1 byte is next subheader, plus 42 plus 5. So the size of it is 4750 bytes is your MAC PDU size. And again, because we have requested for the padding for the status report by setting the polling bit to 1, immediately UE need to transmit the MAC PDU containing the RLC status PDU in it with the acknowledgement sequence number set to 2, because sequence number 1 is also received successfully at the mobile. So if you receive the acknowledgement, we know that this sending is successful. If we did not receive the status report, something happened. So this time we are setting it 130 bytes with polling bit set to 1, again with extension bit set to 0, and the LCID is 11, only sending the MAC PDU without padding. Even in this case also we expect the status report. Padding is present or not present doesn't matter. So when the padding is present, UE's MAC layer must be able to decode. When padding is not present also, UE's MAC layer must be able to decode properly in both scenarios. So we are receiving the status report. So if you receive the status report means test case passed. If it is not received, then test case will be announced as failed. Okay. Now here we are transmitting multiple PDUs. The full explanation is there for those multiple PDUs that we are packing. So if you study it in shortcut here, the MAC PDU is going to contain subheader and 4 such subheaders you are going to have, where extension bit is set to 1 and the data is 43 bytes. Four of them. First one is 129 bytes. 127 bytes of his data, 2 bytes of padding. Remaining all are 43. So it is 41 bytes each, 4 of them. Totally 5 plus another 129 bytes. All belongs to the same logical channel number 3 only. So MAC is multiplexing the data that belongs to the same logical channel, multiple PDUs. Again, another 543 bytes. So totally how many we are sending, how many total PDUs we are multiplexing is 1 plus 4, 5. Another 1 here plus another 5, 11. So totally 11 RLC PDUs or MAC SDUs are being multiplexed, 11 of them. So the last sequence number from the previous sequence numbers, previous sequence number is sequence number 2, here starts from 3. So sequence number 4 to 8. Next sequence number will be from what? Next sequence numbers are not mentioned here. Ultimately, okay. Oh, no. I think what is the problem? Totally, how many are being sent? Only 5 are being sent, actually. So there is some mistake here. Total, only 5 are being sent. 4 to 8. 4, 5, 6, 7, 8. 5 SDUs are being sent. So, so it is little confusing here. I think the first one is 129. Remaining 4 are 43, I guess. Yeah, first is 129. The second remaining 4 are 43. But what are these 5? So this is something wrong here. This 5 into 43 are not being sent, and 129 at the ending is also not there. Totally 5 are only being sent, but this part is not there. Actually, this is the SDUs. Yeah, sorry, my mistake. I made a mistake, not the mistake of the document. So here they are mentioned about the SDU. So the idea is totally they are sending only 5. First, the subheader. Subheader, which is 3 bytes subheader. Next, 2 bytes, 2 bytes, we have 4 subheaders. Followed by that, we have 129 bytes of SDU that is taken from the higher layer. Then 443 bytes we are packing. 543 bytes. So starting from sequence number 3. So for these 3 bytes, sequence number is 3. For these things, sequence number is 4, 5, 6, 7, and 8. Another 2 bytes is there. For 8, 5 subheaders, 5 PDUs. Is that way. It's all confusing me because here if we have 4 used, actually there should have been 5. Okay, fine, leave it. Doesn't matter. Okay, so actually this should have been 5 here if it is 5 here. Okay, so some mistakes are still there for sure. Ultimately, we expect the acknowledgement sequence number with the sequence number being 9. So up to sequence number 8, all the packets are successfully received, and it is a report coming back that at RLC level, a report status report coming back that the next expected sequence number from my side is 9. So then the test case is going to be announced as passed. Okay. Now 7134 is about HARC process handling. So this is about transport block HARC mechanism. So mobile is in connected state and DRB established. UE receives a MAC PDU for a DRB, but CRC fails. UE transmits a NAC for the corresponding HARC process number. Again, DRB established. UE receives a MAC PDU retransmitted for a DRB and results in the CRC pass on combined data. So then UE transmits a ACK for the corresponding HARC process and delivers the data to the upper layers. So first negative scenario, you are sending NAC, but second time, it is a positive scenario. You are reporting ACK. System simulator should contain one cell, and RRC connection reconfiguration should be done according to the table mentioned here. UE is in loopback activated state. So steps 1 to 7 are going to be repeated for each and every value in the table. So multiple times these steps will be executed. First, SS, what we study the steps, then we see the repetition. SS indicates a new transmission on PDCCH, transmits a MAC PDU by indicating a particular HARC process number. HARC process number also will be indicated on the PDCCH channel. But the CRC is calculated in such a way that it will result in CRC error. So UE transmits a NAC, then the test case passed. SS again retransmits, but this time CRC will be perfect. CRC is calculated correctly. Now ACK is expected. When ACK is sent, it is passed. UE transmit a scheduling request on PUCCH. It is still in timing alignment. It can send the scheduling request, 1-bit scheduling request in uplink. Why? Because we have kept it in loopback activated state. So data need to be sent in uplink direction. So SS sends the uplink grant suitable for the loopback PDU to be transmitted. That many resources will be allocated to the UE on PDCCH channel by using the downlink control information for granting uplink resources. So mobile transmits a MAC PDU containing the loopback PDU that is transmitted from step 1 to 3. That PDU will be sent back. We validate this PDU to make sure that it is correct or not. If it is correct, the previous 3 steps are perfectly happened. That means that the MAC PDU transmission in case of HARC failures worked out correctly without having any issues. So we are asking the mobile equipment to send the data back to us and validating it, whether the data that is sent is equal to the data received or not. If equal, very good. Okay. So how many times it will be repeated is 8 times with HARC process number to be particularly 0, 1, 2, 3, 4, 5, 6, 7. So on whichever HARC process number you send the data, in the DCI, downlink control information, you can specify HARC process number. So on whichever HARC process number you schedule the data, you should receive a NAC on that exact HARC process number itself. You should receive the NAC for that process number. Then only we'll announce it as passed. And on the same HARC process number only, we should receive the ACK also. So that is what we are validating here. So every time we are modifying or changing the ARC process number. But in FDD, we have 8 ARC processes. Numbers 0 to 7 are allowed, but in TDD, only 0 to 6, 7 ARC processes. Timing alignment timer is set to infinity in order to make sure you don't need to send timing alignment, control elements very often to keep the mobile equipment in uplink aligned state for infinite time. Correct ARC process handling for CCCH. The previous one is for DCCH when the mobile is in connected state, but this is for the mobile which is in idle state. So mobile is an RRC idle with RRC connection establishment procedure initiated. RRC connection request is sent or something. UE receives a MAC PDU addressed to its ARIA RNTI. What comes on ARIA RNTI is your RAR, random access response. UE does not transmit ACK or NAC for the corresponding ARC process. You should not do because it is not expected. If it is transmitting, then it will be announced as failed. Then you raise a bug report against MAX protocol software. Because whenever you receive something on ARIA RNTA, you are not supposed to send ACK or NAC. It does not transmit. We are not expecting the ACK or NAC for CCCH, especially in this rare scenario. UE is an RRC idle with RRC connection establishment initiated. UE receives a MAC PDU addressed to its temporary CRNTI. Anything that is coming on temporary CRNTI is definitely RRC connection setup message, including the CRI, contention resolution identity. In this case, without UE contention resolution identity matching to the one that is in the RRC connection request message. So, because it is without it, so UE does not transmit ACK or NAC for the corresponding ARC process, even in this case also. Because CRI did not match, you should not send ACK or NAC. That's not for you, even though temporary CRNTI matched. So you think that something wrong is going on in the random access procedure. Maybe somebody else is also using the same temporary CRNTI as yours. Because your contention resolution identity did not match, you have to restart the random access procedure once again. But finally, it is addressed to the temporary CRNTI, and we are making sure that it cannot decode it properly. We are making sure the CRC is failed. In this case, UE does not transmit NAC for the corresponding ARC process. So even on the temporary CRNTI time also, you are not supposed to send the NAC. But final case is MAC PDU with address to its perfect CRNTI, and UE contention resolution identity is also matching, and everything is decoded properly. Now only mobile is allowed to transmit acknowledgement for the corresponding ARC process and deliver the data to the upper layers. That means in CCCH cases, transmitting the NAC is not allowed. Even when we are transmitting the data on the temporary CRNTI, you are not even allowed to send anything when you are receiving something on ARIA RNTI. ACK or NAC, both you cannot send. But on temporary CRNTI, if CRI did not match, you are not supposed to send anything. If CRI matches but you can't decode the data, you should not send NAC, because NAC sending is not allowed. Only ACK sending is allowed on temporary CRNTI. So there are different mechanisms in ARC process handling for different cases. So the same things will be checked as part of the steps. So SS transmits a paging message for the mobile who is in idle mode, which is already registered but in loopback state. So suddenly when you receive a paging message, you know that you have to establish RRC connection. Mobile start transmitting the preamble on PDAC. So we are sending the random access response, but we are sending it on the random access response on the random access ID, RARNTI, but CRC is calculated to make it wrong. So we are not expecting ARC ACK or NAC. If ACK or NAC are received from the mobile, it is announced as failed. UE again should transmit the preamble once again. Again, random access response. This time, CRC is perfect. But again, we are not expecting ARC ACK or NAC. If ACK or NAC is received, again, we will announce it as passed. Failed, not passed. Sorry. Now, UE transmits the MAC PDU containing RFC connection request, message 3 transmitted. So that means the previous resources are allocated successfully. So it is transmitting the MAC PDU. And SS transmits a valid MAC PDU containing the setup and the CRI. But this time CRI is not matching. We are making sure that it is not matching. And UE should not send ACK or NAC. If it is sending fail, again start the preamble procedure one more time. Again, we have ARIA, temporary CRNTI is issued to the mobile on its ARIA RNTI as part of random access response. Mobile transmits the message 3, RFC connection request, and then MAC PDU containing the setup and the CRC is CRI matched, but CRC is wrong. So when the CRC is wrong, that time also we are not expecting it to send a NAC. If mobile sends the NAC, it's failure. Because only allowed mechanism is acknowledgement. So now everything is repeated, but this time we are making sure that the CRC is passed and mobile is finally reporting ARC acknowledgement. And after that, mobile would send RRC connection setup complete with service request, which will be rejected and the test case will be terminated. Because our actual procedure testing is completed. So number of times the preamble is allowed to be transmitted is 8 times. Contention resolution timer is set to 64 subframes in the SIB2 system information block that the system simulator is going to advertise to the mobile. These are the parameters that specifically must be set. And PRACH configuration, like which resources should be used, doesn't matter, some configuration. Okay. Correct ARC process handling for the BCCH channel also. When it's transmitted, MAC PDU address to the SI RNTI, system information RNTI, mobile should not send ACK or NAC. Even though it is decoded by the ARC process, it should not send ARC, ACK or NAC. Not advisable. So we simply send it and check whether ACK or NAC is sent back or not. So you are addressing it as SIRNTI, system information, but CRC is failure. Even if CRC is failed, mobile should not transmit ACK or NAC. If mobile transmits ACK or NAC, it's a failure. Again, one more time, CRC is passed this time. But again, ACK or NAC should not be sent. If it is sent, failed. But because mobile equipment is in loopback state, if any MAC PDU is sent, so if mobile sends the scheduling request, system simulator is configured not to allocate the resources. So obviously, when a MAC PDU is sent, acknowledgement is reported, but on the PUCCA channel, But to transmit the data back, you require resources. But System Simulator decided to not to allocate the resources when scheduling request is sent. So mobile don't have any choice. When it is sent the scheduling request, resources are not granted. Only the choice to get the resources is to start the random access procedure. So it is starting the preamble and random access response, and resources are granted. By using that resources allocated against the mobile CRNTI, the loop back packet would be transmitted back to the system simulator. And the step is done. And the test case logic execution is completed. Again, what parameters? Just two more simple things are there. We'll finish them off. MAC padding. UE is in connected state. It receives RLC PDUs with MAC PDUs with padding greater than 2 bytes. UE acknowledges the reception of the PDUs, normally because it works in AM mode. At RLC level, acknowledgements will take place. Connected state with padding equal to or less than 2 bytes. Even in that case also, it must receive the data. SS is transmitting MAC control timing control element, timing advance command with padding equal to less than 2 bytes. And node data MAC PDU subheaders are followed by transmitting the MAC PDU. Only it is transmitting the control element plus padding. In this case, UE acknowledges the reception of the RLC PDU using the new timing advance. It must apply the timing advance. We are validating that. So that means we are validating mobile equipment's decoding capabilities. It is decoding the RLC PDU, throwing the padding into dustbin, sending the data to the higher layer. Higher layers will acknowledge it. So we know that MAC decoding operation successful. Here also the same thing. But here it is greater than 2 bytes of padding, less than 2 bytes of padding, or equal or less than 2 bytes of padding. But in this case, padding is less than 2 bytes, but we are not sending any data PDU. Instead, we are only sending control element. Control element plus padding, that's all. Without any RLC PDU. But this time, mobile should apply the timing advance issued. Next time onwards, whenever it is sending any uplink PDU, it must be using this much timing advance that is suggested in this control element called as uplink control timing advance control element. So it's a timing adjustment we have received. Mobile should apply the timing adjustment. So system simulator should contain one cell. UE configuration preamble is in loopback activated state. RLC SDU set to no return of uplink data. So SS transmits a PDU. So, and as usual, mobile is sending RLC status PDU passed with 7 bytes of padding used in the MAC level. 1 byte of padding used. In that case also we must receive the status report because polling bit is set to 1. Whenever the polling bit is set to 1, RLC will immediately send the status report. So status report sent, passed. SS sets the downlink assignment for TBS, transport block size is 16 bits, 2 bytes. And MAC is preparing the timing advance command, which is 1 byte, maybe 1 byte padding. So you are just sending that much size, just to timing advance. This time without any padding. Next time we are sending the control element plus 1 byte of padding by setting the transport block size set to 24 bits, 3 bytes. After the second scenario is executed, there is a timing adjustment sent, timing advance is sent. Now, because the mobile is in loopback state, so we are sending a MAC PDU. It is supposed to send the status report to whatever that is received so far. It need to send the status reports. But while sending the new status report for the new PDU that is being received, mobile must have applied the timing advance that is issued in the previous command. If instead of using this much timing advance, if it has applied the previous timing advance, then the test case will be announced as failed. But if this new timing advance that is received is applied, then the test case is going to be announced as passed. So basically, mobile must follow the timing adjustment that is suggested to you by the eNodeB. MAC reset in a downlink operation. UE is in UTRA RRC connected state. UE MAC is reset due to handover to a new cell. UE flushes the downlink ARC buffer. What is the meaning of reset? Reset means you have to give a restart. Whatever the previous operation that you are doing in the old cell, you should not continue in the new cell. You have to start the operation freshly. That's called as reset. So typically these resets will take place whenever handovers happen. So in such cases, if the downlink ARC is storing any previous PDUs, previous transport blocks for the purpose of retransmission, those MAC transport blocks which are stored in the ARC buffer must be discontinued, must be flushed out, will be thrown into dustbin. Same RRC connected state, MAC is reset due to handover to new cell. UE considers the new transmission for each downlink ARC process as very first. So it is going to be considered as first time transmission. It should be considered as in the new cell, not in the old cell, in the new cell. How do we test is interesting. The second part testing is very, very interesting. How do we know that it is considered as first time transmission? We set a maximum transmission time, so that many times it should attempt. Okay, next. SS ignores the scheduling request, does not allow any uplink grants. SS transmits a MAC PDU containing one RLC PDU SDU on DRB, but the CRC is calculated in such a way it is containing erroneous. So NAC is received. Fine. Normally, in this case, how many cells are required? 2 cells are needed because we require to simulate handover. We are going to have cell 1 and cell 2. The UE is in state loopback activated state in cell 1 at the starting with the DRB present with the default EPS bearer context configured in RLC UM mode. So RLC is present in the UM mode, not in AM mode, acknowledged mode, no status reports in UM mode. But in cell 1, okay, so what's going to happen at T0 time? We are going to make cell 1 power to be minus 90 dBm with the cell 2 switched off. At T1 time, cell 1 power is on the reference signals is continued to be minus 90 dBm, but cell 2 power is minus 80 dBm, where mobile will feel that cell 2 is better than cell 1. So we are making use of 2 cell transmitters here. So obviously mobile will feel that cell 2 is looking better for him than cell 1. So it will propose handover. It will request handover from the eNodeB. Suddenly when cell 2 became minus 80 dBm power level cell at T1 state. So this is the T1 state right now. SS changes cell 2 level according to the T1 table. So it It has applied minus 80 dBm power for cell 2 transmission. Cell 1 continued to be minus 90 dBm. So definitely mobile feels that cell 2 is better, and it may require handover. But meanwhile, SS transmits RRC connection reconfiguration to request for the uh, you know request for something called as measurement reports, which we will study as part of RRC protocol. But once mobile equipment have sent the measurement report, SS transmits RRC connection reconfiguration message to tell the mobile equipment that, hey, you have to go to the cell 2 by leaving cell 1, and by providing an random access preamble, explicit random access preamble. A special preamble would be provided to the mobile for performing non-contention based random access procedure. So UE stops transmission on cell 1 and starts linking on cell 2, complete the synchronization on cell 2. So it is performing, mobile equipment performs RRC connection reconfiguration complete on cell 2. This is the message 3, with which you will report to system simulator that you have arrived at cell 2. Now, what do we check? Mobile is already in cell 2. We will validate for 100 milliseconds, mobile does not transmit any HARC NAC. Why? Look at this carefully. eNodeB sent a MAC PDU from cell 1, for which mobile reported NAC because CRC is wrong. What eNodeB is supposed to do is retransmit, but without retransmission or before retransmission, handover occurred already. Mobile moved to the second cell. So now, what is mobile supposed to do, especially in case of reset scenarios, is it should not bother about the procedures it is performing in previous cell into the next cell. It should not continue those operations. For example, if mobile would have continued in the cell 1 itself, what happens? Mobile would have transmitted HARC NAC one more time after some time. eNodeB is not transmitting the PDU. After some time, it would have transmitted the NAC once again to advise eNodeB to transmit the MAC, to retransmit the MAC PDU. It would have done that. But because mobile moved to the new cell, it should not transmit the negative acknowledgement to advise the new eNodeB to retransmit the PDU once again, the failed PDU. If at all mobile sent the NAC, then the test case will be announced as failed. Why? MAC reset did not take place. That means that MAC did not forget about whatever it is doing in the old cell and not starting freshly in the new cell. Instead, it is continuing the old baggage into the new cell, which should not be the case. When you go to the new cell, you should start your operations afresh. So you wait for 100 milliseconds to see if the mobile sends the NAC for the previously received MAC PDU. If it did not send, the test case is passed. If it is sent, this is failed. Then SS transmits the MAC PDU containing the RLC SDU on the DRB, and the NDA is set as the same NDA value because it's not the new data indicator. New data, it is old data itself. MAC PDU is sent. One RLC SDU, 40 bytes on DRB. Now, this data is sent successfully without any CRC errors. Of course, does UE transmit the scheduling request to request for the resources? Because mobile is in loopback state, it is supposed to send the data in uplink. So it is sending the scheduling request. This time we are allocating the uplink grants by reading this scheduling request arriving on PUCCA channel. So uplink grants are allocated for the SDU data that need to be looped back, and mobile transmits that MAC PDU. With that step, that is completed. The operation is done. And that's it. That is the end of 713 for us. the downlink ACH cases.